So, homework for Chapter 5 and Chapter 6 that's being asked. 6.57c. Alright, so this is I need a pen. Reduce. Alright, page 290. 6.57, letter C. They give you a reaction of 1/8. Alright, 1/8 of S8 plus S8 solid plus H2 gas yields H2S gas, and they give you a delta H equaling negative 20.2. Okay, so that's for the forward reaction, 20.2 kilojoules. Now, the rule is the following. Okay, if I have a delta H, all right, and we look at the reverse reaction. Okay, so the reverse reaction is the opposite sign. Okay, so reverse reaction, same number, opposite sign, 20.2. They're not asking that, but I'm just reviewing. So reverse reaction, change the sign, keep the number. Okay. Now, what they're asking here is, what is the delta H when 2.6 moles of S8 reacts? So in letter C, they're saying, we're going to use 2.6 moles of S8. What is my new delta H? Okay. Whatever I multiply the reaction by, I need to multiply my delta H by. Okay. So whatever I multiply, so let's say I want to double everything. Then I will double my delta H. So what I have to figure out is how many 1/8 are in 2.6. And if I do the math, 1/8 as a decimal is 0.125. So 2.6 divided by 1/8, okay, ends up being, okay, 8 is our answer. All right, because I'll take 2.6. I'll double check my math here. 2.6 divided by 0.125. Oh, it should be 20.8. Sorry. Because I got to figure out how many. Yep. I'll do this right yet. 1 divided by 8. Okay, 0.125. 2.6 divided by 0.125 is 20.8. Okay. Yep. Yep. Double checking my math here. So, in order to use 2.6 moles, I have to multiply everything by 20.8. Okay? Then I take 20.8 and multiply it by negative 20.2. And that should give me my new answer. 20.8 times 20.2. And I'm getting negative 420. 0.16. So if they wanted to know 2/8 or 3/8 or whatever it is, you would multiply by 2. Whatever you multiply the reaction by, you have to multiply your delta H by. So you have to figure out, well, if I want to use 2.6, we got to remember that our stoichiometric coefficients mean moles. If I want to use 2.6 moles, then I have to multiply this by something to give me 2.6. I can't just turn this into 2.6 because then that changes the balanced equation. So 20.8 times this will give me my 2.6. And that's our delta H. Now the other question I see is 6.72, which says, write the balanced equation. Pull it closer. Write the overall balanced equation for the following. So all they want you to do here is add two equations together like you were doing algebra. They're saying you have two equations. How would you add them together to get your third equation? So, on the same page, (6.72) gives you two equations. It says N2 plus O2 yields 2NO gas. N2 gas plus O2 gas yields 2NO gas. Right? And the delta H is 180.6. Then it says 2NO gas plus O2 gas. 2NO gas plus O2 gas yields 2NO2 gas. And they give you a delta H for that one. Negative 114.2. Okay, I'm just going to add the two equations together. Just like in algebra, if something's on the left-hand side and on the right-hand side, they can cancel each other out. Add up like terms. So I'm ending with N2 gas plus 2O2 gas yields 2NO2 gas. And the delta H equals, we add these two numbers together. (180.6) plus a negative 1 or minus 114.2, and the answer is 66.4. Like so. Now, if I had to flip my reactions or something like I showed in the videos, the delta H's change sign. If I have to multiply, my delta H's, all right, change by what I have to multiply by. All right, questions on this? Let me bring the camera down just a little. There we go. they wanted you to write the new reaction out with the delta H. It says, write the balanced overall equation number 3 for the following process and calculate the delta H. So they wanted both. So the exam is going to cover, the exam tomorrow is going to cover chapter, and this is dying on me. Chapters 5 and 6. So you should be able to do all your stuff with PV equals nRT. P1 V1 equals over N1 T1 equals P2 V2 over N2 T2. You should be able to do gas stoichiometry. Dalton's law of partial pressure. Over here, with chapter 6, you should be able to do Q equals MC delta T. Okay. You should be able to do Hess's law, which is the stuff I just did. One part of Hess's law and the other part, so there's two parts. There's the, calculating it from other equations. And then there's the other one where it's calculated from using Appendix B. Okay. And then Thursday will be an exam on just Chapter 7 and 8's presentations. And we'll talk about that on Wednesday. But I put Appendix B up under the assignments on Blackboard. So when you log in to take the exam tomorrow, Appendix B will be there for you. If you don't have your book. Okay, but that's really the topics that are covered in Chapter 5 and 6. Gas laws and gas stoichiometry, Q problem, and Hess's law. So there really isn't that much separate information. Now, Wednesday, I'll break down the exam on Thursday. A handful. I made it up on Thursday, so I can't remember exactly. I think there's maybe 8 or 9 questions, math-wise. Something like that. 7? I don't know. Same kind of setup. Math problems with multiple choice answers. I think I gave you almost 2 hours to do it. going to check right now. I'm pretty sure I made it 2 hours. Yeah, 2 hour time limit. Two-hour time limit. $14 math questions. It's 14. I just double checked that too. First, the second exam, the range was 49 points. The highest grade was 100 and the lowest was a 51. I had a couple of 100s. I had some 95s and 97s. So it was something like that. If you scored... I added 4 points in to your grade if you were below a 95, because adding 4 points to a 95 or above does absolutely nothing. So there was a 4-point curve, but I can't give 104. I mean, a 99 versus a 95 doesn't make a difference. I've seen, let's put it this way, Ellen, I've seen worse under better circumstances. How about I say it like that? So I've seen worse where we were able to cover the stuff in a normal time period in a classroom under a normal setting, where I've seen the range be about 80 points on this exam, where people got hundreds and people got 20s. So to have my lowest grade to be just barely below the, failing mark, I'm pretty happy with the work you guys did. Even if you had that failing mark, I wouldn't worry so much about it. Just don't do it again on the next 2 exams. That's what I have to say. Yeah, so you are doing pretty good then. Altogether, you're all doing pretty well. Even those of you I know who are upset and in my email saying, I'm worried, blah, blah, blah. I'm not worried yet. This exam is usually the better grade. So we'll see. Now, if everybody did poor then that's something I'd have to look into. But when there's hundreds and 90s and things like that. But like I said, I didn't have any 20s. I didn't have any 10s. I didn't have any 40s. And I usually have that when we take, 3 weeks to cover the material, and we're in the classroom, and I'm always available in my office hours to you. So I was, very happy with the grades, even though some of you weren't happy with your grade. And not to get on my soapbox here, but if you continue to worry about grades and that you need an A or you need this or you need that, you're going to have a mental breakdown hardcore. Yes, you want to get good grades, but that's not the only thing places are going to look at. No, that doesn't count for anything, Vaughn. That was more for financial aid. But I know people who got C's in Gen Chem 1 and are PAs now and all of that. And I'm telling you from experience about having to get an A in every course and having a mental breakdown, because I know it from personal experience. The pressure I put on myself in school caused a lot of problems. And I don't mean just in college. I mean throughout all of I'm a perfectionist. It's not good. You're not going to get A's in everything. But if you can look in the mirror and say, I put in my best effort and that was the best grade I can get, then that's the best grade you can get. I'm telling you right now, they're not going to hold you back. But I need to get into X. No, you don't. You want to get into X, and guess what? If you don't get into X and you get into Y, and you graduate through Y's program for the same thing you were going to do at X's program, you're going to have the same job. Okay, I just was talking to her this weekend. There was a girl that I had up at Keystone who didn't get into medical school, and she wanted to go to Cornell and Michigan State and all the top schools. And she worked her butt off for the next 2 years and got into the University of Grenada. And she got to do her postdoc and finish up everything at a Big Ten school, University of Illinois. And now she's a vet, and she's working in Scranton starting this week. Guess what? If she went to Michigan State or Cornell or anything, she'd also be a vet, working probably in Scranton this week. So what I'm saying is, yes, put pressure on yourself, but be careful. Grades aren't the most important thing. Yes, you can't have a whole bunch of F's and D's. No. But a C here or a B minus there or whatever is not the kiss of death where everybody thinks it is. Yeah, I could go over 6.38. 6.38. Let me find it. It says calculate Q when 0.10 grams of ice is cooled from thing, and it gives you the C of ice. Okay. So, this is a Q problem. 6.38. Where'd my... I had all these ones that I know work. Here we go. 6.38. Page 289. 6.38. And we're going to use Q equals M, which is mass in grams. Okay, mass in grams. C, which is the specific heat. Times delta T, which is TF minus TI. T final minus T initial. Okay. So they give you the mass of the ice. So Q equals, the mass is 0.10 grams. They give you that. They give you the C of ice, 2.087. 2.087 joules, grams, Kelvin. Now you could change it to Kelvin if you want to, the temperature. You don't have to, because the change is still going to be the same value no matter what, from Celsius to Kelvin. So ice is cooled from 10 to minus 75. So final is negative 75. Minus the initial, which is 10. Okay. So we just plug the numbers in. Our units are good. 0.1 times 2.087, which will be 0.2087, times negative 85. I'm getting negative 17.7. And then grams would cancel out, and our temperature would cancel out, so we'd be left with that many joules. So what that means is this is losing heat, because the negative just means losing. Yep, 8 a.m. to 8 p.m. again, Erica. You need a 70, Vaughn. In my class, because there's no minuses at LCCC. So a 70 is a C in my classes. They have no minuses, they only have pluses. right, Sonia, that's how you do that one. Let me see one that does that. 6.41. Okay, or... Yeah, 6.41 does that. Yep. I'll just make one up based on that, though, because they use iron bolts, and that's fine. I'll just make up a problem that does the Q equal to each other. So let's say we have a container, okay, and it's an insulated container. So we don't have to take the container into account. So it's insulated. That means the container, all right, is, well, I might as well spell insulated. All right. The container is, whatchamacallit, not going to absorb any heat. So let's say we put a bolt in there, like so, or nail or whatever, and we put another nail in there touching it, like so. Okay, and we'll call this A, and we'll call this B. Okay, again, now I'm going to make up the numbers here. So here's the information about A. Okay, A has a mass of 1.2 grams. Its heat capacity, it's letter C, all right? So its mass is 1.2 grams. Its heat capacity is, I don't know, 0.876 joules, grams, degrees Celsius. And its initial temperature is 100 degrees Celsius. For bolt B, it'll have a mass of 2.4 grams. Okay, its C value is 0.612 joules, grams, degrees Celsius. And its initial temperature is 40 degrees Celsius. And I want to know what is the final temperature these bolts will come to. So what we have to remember is heat travels from high temperature to low temperature, which means that A is going to lose heat and B is going to gain heat. Okay, so if I want to set that equal to each other, all right, the Q of A equals the Q of B, but A is going to be negative and B is going to be positive because the heat's going to go from 100 to 40. Okay, so to write this out, and I would take the time to do this, okay, so I'd have the mass of A times the specific heat of A, and since it's the negative, the negative is initial minus final. Now I'm going to set that equal to B. I'm going to have the mass of B. I'm going to have the specific heat of B. And I'm going to have final minus initial for the positive one. Okay? Now, plug in my values. Since this is A, my mass is 1.2 grams. My specific heat, they gave us, and this is just like the problems in the book. Okay, there's our specific heat. I know my initial temperature is 100. I don't know TF. The mass here is 2.4. The specific heat is 0.612. And the initial temperature is 40. And now you'd have to work out all the math here. Okay, so 1.2 times 0.876. All right. 105.12 minus 1.05 12 TF equals, and we do the same on the other side here, 2.4 times 0.612 equals 1.4688 TF minus times 40, 58.75. And I'm running out of board space, but you would combine your TFs, combine your like terms. So I would take 105.12 added to 58.75. All right, I get 163.87 equals, now I'm going to bring that over here, 1.4688 plus 1.0512. I get 2.52 TF. And now solve. Take 163.87 divided by 2.52. And I get a temperature of, my final temperature will rest at 65 degrees Celsius roughly. Okay. The key is make sure you show which one loses and which one gains, because that's going to determine what this looks like. Okay. So that's the type of problem I think you're looking for. And then homework problems like 6.41 on to like 6.46, 6.5, all of those deal with that kind of problem, solving for different parts. Some solve for like the specific heat of a thing, some solve for the mass, but they're all doing the same process. That's what it is, Vaughn. It's plug and chug as long as you're in your right units and you understand what's going on. And that's why everybody does I told you guys that 3 and 4 is the hardest exam. And then everybody bounces back in 5 and 6. That as long as you're in your correct units and you're in your correct everything, you are right. Yeah, if you're going to use PV equals nRT and you're going to use R as 0.0821, Your volume has to be in liters, your pressure has to be in atmospheres, you have to be in moles, and your temperature has to be in Kelvin. It's the only way that'll work. If you don't convert them, everything is going to be wrong. And Eric, I just checked. The exam is actually open. I have it from 8 a.m. till 11:59 p.m. is when you could start it. All right, what else can I do for you guys? Exam 3 is over with. Okay? Exam 2 is over with. I should say chapter 3, 4 exam is over with. Get it out of your head. There's nothing we can do about that.